Welcome to qnawire.
Alright, so we are first being asked to find the vertical and horizontal asymptote. So, this function can be rewritten as 1 over e to the x squared. And now, if you haven't already noticed, this bottom function of this function denominator could not equal 0 because that's what defines vertical asymptote. That's one of the ways. And since exponential functions never equal 0, there is no vertical asymptote. So no vertical asymptote. And so now we got to find the horizontal asymptote. So we find that by applying the limit. So the limit as x goes to infinity. And this will be 1 over e to the x squared. And as you can see, as if this number gets, the denominator gets exponentially higher, you get 1 over infinity, which is just 1 over a really big number is just 0. And this is the case also for negative numbers, because negative numbers squared is the same thing as positive numbers squared. So this was also plus or minus infinity, so we have a horizontal asymptote at y equals 0. And then now, to find the intervals in which function increases or decreases, we apply the first derivative test. So that means taking the first derivative. In this case, you will have to apply the chain rule. So it'll come out to be negative 2x equals negative 2x times e to the negative x squared. Oh, sorry about that. Let me just bring this down. I was just a negative 2x, so e to the minus x squared. And this can be rewritten as negative 2x over e to the x squared. Then you set this equal to 0. The denominator cannot equal 0, so that's not one of the critical numbers. Negative 2x equals 0 when x is equal to 0. So we have a sign chart evaluation here. So it's going to be x, and you put it at 0, and then you bring it down, and then we're looking at the sign of f prime. So if you plug in numbers less than 0, you get positive numbers, and you plug in greater than 0, you get negative numbers. So we know it's increasing and decreasing, so we have a local max occurring at x equals 0. And we know that it is increasing from negative infinity to 0, and it is decreasing from 0 to infinity. Now to find where the function is, find the function's concavity, we take the second derivative test, and that means finding the second derivative. So again, this is a little bit more chain rule and combination of some product rule. And this will come out to be negative 1 plus 2x squared. Set this equal to 0. This part of the function cannot obviously equal 0, so we have to set this part of the function equals 0. So this will be negative 1 plus 2x squared equals 0. To find our critical number, you add 1 divided by 2, so you get x squared equals 1 over 2. And this will be x equals, the square root of 1 is 1, so it'll be 1 over root 2. Plus or minus, because we took a square root. So now we can do a sign chart evaluation. This will be negative 1 over root 2. And this will be positive 1 over root 2. Bring down the line, looking at the sign of f double prime. So you plug in values less than negative 1 root 2, you get positive numbers between these two, negative and positive. So concave up, down, up. So we have a concave up interval occurring from negative infinity to negative 1 over root 2. And from 1 over root 2 to infinity. And we have concave down occurring between negative 1 over root 2 to positive 1 over root 2. And we have inflection points occurring when sign change occurs. So that occurs at both plus or minus root 2. Plus or minus 1 over root 2. So inflection point occurs at plus or minus 1 over root 2. Now we have enough information to draw a graph. So it looks something like this. We know that there is a local max at 0, and we have a concave up shape from here, from the negative. So we kind of coming up like a U. So this is like a up U, and then it'll turn into a concave down shape. So now we start decreasing after 0. And you come down, and then it'll go off to 0. And this max is occurring like right here. The peak is supposed to be at 0. Sorry if that wasn't clear enough, but this is the graph of f of x, and it's symmetrical. That's it.